Now that we've had some time to build some surfaces and get familiar with that, I want to make sure you understand some of the terminology out there. So when you go into production, you have a clue what people are talking about. Starting with the detail parts. A detail part simply is just a single individual part that's going into an assembly. For example, this is a toggle clamp. That's an assembly, and all these are the little pieces it took to make up this toggle clamp. And up here we have surfaces. These are surface elements. This is an assembly because you have a dumbbell and then you have the plates on there. So the individual pieces are the detail parts. All right, so I'll close this off. This is a detail part. It's a single part. It was done in the part design workbench. If there were two pieces in here, it will become an assembly. This is a single part, so therefore it's a detail part. Some people make the mistake of building an assembly in the detail part, but really how it's supposed to be is every little individual piece is its own piece, its own individual part model, and then it's merged into an assembly. For example, this is your assembly here. So you have a toggle clamp assembly here, and over here we have a surfaces, right? So these surfaces have no density. They're infinitely thin in material, and they just usually represent the outside surface of something. Um, for example, if you were going to wash your car, you're washing this part of the surface, that would be known as the surface that you're working on, not the actual thickness of the material. That would be done in the part design environment. So the surface, you can Google that, define surfaces. It's just usually the upper or outer surface of whatever it is you're working with. So there's a couple definitions. Now I pulled this up because a lot of people are pulling up these definitions without watching the video, and I'm like, no. You need to watch the video and see what I'm saying is definitions. Now you have surfaces and then you have points, lines, and planes. That's all construction geometry. Everything that goes into the geometrical set is considered construction geometry. The only thing that goes in the part body is the solids itself. Back in the day when we first started doing CAD design, I'm going to date myself, we didn't have solids. You couldn't make a solid feature. Everything was only lines. So every edge of a part was represented by lines and circles, and you had to create every little edge. Now it's so easy, you just create a 2D profile and extrude it, and you got half your part done already, if not more. So construction lines are just basically elements, or construction geometry are just elements used to support making the solid entities. All construction geometry, again, goes into a geometrical set and renamed to construction geometry. And then if it's a solid, it's in the part body. Okay, so in your form here, it says to define MDS. MDS, so some of the students have been Googling the acronym MDS, and nope, this is not what I want to see. I don't want to see anything about our health or whatever symptoms we might have. This is not the correct answer. We're talking about MDS in surfacing terms. MDS is a master dimension surface. So, for example, if you've designed up the next Tesla, the outer shell of the car would be the MDS. All right, so the entire outside surface that represents the vehicle, that would be your MDS. That's the master dimension surface. And an OML is not, oh my lord, do not put that on the answer sheet. I know you were Googling it and got it wrong. I know you didn't watch this video if you put this down. This is not what we're looking for. An OML surface is the outside mold line. Okay, outside mold line is what it stands for. It's typically the outer surface. So for example, if you're working on a hood of a car, you're designing that hood, The top surface where you're polishing and waxing, that surface would be your OML, as opposed to the IML, which is not some kind of security thing. If this is what you put, you're getting it marked wrong. That is not correct. IML is the inside moldline surface. It's usually an offset of the OML. So for example, the inside thickness of the part when you pop the hood open, the surface that you're touching there, that is representing your IML. So the MDS would be everything here in yellow. That whole surface out there, that's the master dimension surface for my truck here. Um, the OML would be all the little pieces it took to make that up. So you're not going to get this all done one surface. In fact, even looking at this fender, this is probably going to be a surface on its own, and then this is going to be a surface on its own, and then these are going to be individual surfaces. And you're going to have one join surface just for that fender for all those individual pieces. The individual pieces are the OML of the surface. The one surface that represents the entire fender, that is known as the master dimension surface. So for that fender and that piece, when it goes on to the assembly, that whole piece, that's the MDS for that fender. And then when it's all assembled and put together, the MDS is all the surfaces that represent the outside of this vehicle. Inboard is on the inside of the plane or ship. Um, People are Googling outboard, inboard. I'm not looking for the motor here. Inboard, they have a definition. It's inside the fuselage of the aircraft or the motor mount side of where the hull is. It's pointing to the inside, where outboard is pointing outward. So to help you better understand that, maybe I'll talk about station line, buttock line, water lines. The aft of the boat is toward the rear, and the forward section is toward the front of the boat. Okay, so the term aft, oh, I didn't add that. That term aft will be noted on here. You got aft and forward that you need to learn. So that's the aft of the ship, and the coordinate system actually came from maritime design. So ships used station line, buttock lines, and water lines to use that as an index to build ships. So if we're looking on the inside of the plane looking forward, to the right here is the right buttock line. To the left here is the left buttock line. So they identify BL over here telling me that this is the left side of the boat or the port side. And this here is the starboard side, it's the right side of the boat. And then here you see water lines from the bottom up. So water lines are going straight up and down. And forward and aft is representing station cuts. So another picture of this, the forward part of the boat is the forward section here, and as you go towards the back, that's heading towards the aft side of it. These use those same coordinates for aircraft design and automobile, and a lot of other types of companies use that same coordinate system that was created years and years and years ago when they were doing wood ships. So you can do some Google searches and find that, type in this for a search. I actually think a lot of the aircraft design does a better job of explaining forward and aft, station line, buttock line, water line. But again, this is just kind of a isometric view. This is called center line, right down the center of the boat. And all these values over here represent the left side of the boat or the port side. And all these values over here represent the right side of the boat. And those are called your buttock lines. See right here it says buttock lines. And then you have waterline planes. All these planes going from the bottom up are waterline planes. And these form planes are known as your station cuts going forward and aft. So from the front of the plane going back, or from the front of the ship going backwards, is known as the station cuts. And the station cuts go along the X vector. So X direction represents station cuts. And again, a lot of other companies followed suit and just went with maritime coordinates using that same coordinate system as an index. I was looking for, so outboard is on the outside and inboard is on the inside. So if I come back to this picture, where did I have that? Oh no, I had it. I think that was the one. So if we're looking at the inside of the boat, on the left side is the port side here. Anything from the center pointing out is pointing outboard, and anything from the outside pointing in is known as inboard. Okay, so that's outboard, inboard. Station line goes along the X vector, buttock line goes along the Y vectors, and water line goes along the Z vector. To me, that's the one that makes the most sense. Z is your tertiary axis. Z is always up and down. So to have the water line going up and down, that makes sense to me. Then the other one's kind of arbitrary, but Y represents left to right, and station line represents forward and back. All right, hopefully that gets you familiar with some of the terminology, so when you go into production, if they're using these terms, you understand what they're saying.